The goal of this problem is to show that this function is continuous at a is equal to -1. In other words, you want to show that the limit as we approach -1 in the function is equal to the value of the function at -1. If you put -1 into all the x's, so the value that you're going to get down here is 81. So we'd like that this limit through this process also equals 81. Those two things being equal means the function is continuous here. So to start with, going from this step to this step, I see that there's a power of 4 here and here. So essentially, we're just replacing f of x with its function. But I'll just put the x plus 2x cubed since we already have this fourth. So that's going to be x plus 2x cubed. For this next line, it's saying that we're using something called the power law. When we discuss these types of laws in class, it's not really important that you know them by name. You just have to make the observation of what changed from going from here to here. Notice in this step, the limit is outside of the parentheses containing this power of 4. And in the next step, it's now inside the parentheses containing the power of 4. If you could call this something, it'd be called the power law because you're moving the limit inside the expression that has the power. So essentially, what we're going to do is put limit, copy down x plus 2x cubed here. So this is x plus 2x cubed. So you can think of this power law as moving the limit inside the thing that has a power. Now for our next step, there's this thing called the sum law, and here we have two things that are added together. In class, when we discussed this, we said that if there's a sum and you're taking its limit, and both exist, you can break it up into the sum of two separate limits. So notice that this x appears here, and we're taking the limit of it, but you can also take the limit of this piece separately. So here I'm going to put 2x cubed. These terms sound much fancier than they really are. It's just identifying how you're going from step to step. Okay, next it says, all right, going from this step to this step, I see I have this x here, I see I have this 2x cubed with the limit, but the 2 is no longer here. So what would go in this set of parentheses here? Well, you're allowed to remove constants from limits, so you can like pull this value of 2 out, and that's what should go in this set of parentheses. So I'll just jot down that this is a 2, and what we did is we removed a multiple constant from within the limit. So by factoring out this 2, we have to call it something. It's referred to as this. Okay, next is something we talked about in class, which is called direct substitution. Essentially, at this stage, you can take this x and plug in a -1. So by putting -1 in place of this x by direct substitution, you get -1. This 2 here is this 2 here. The thing that goes in this set of parentheses is going to be something to the power of 3. Well, that's going to be -1 to the power of 3. You put this all together, the final step, this is just a number. This is -1 plus 2 times -1, all cubed, then raised to the power of 4. If you do this in a calculator, you do in fact get 81, which is great because all this work shows that the limit as x approaches -1 of the function is actually equal to the value of the function at -1. And this is the definition of continuity.